All right, there it goes. So we will go ahead and start our third lesson of Chapter 9 today. In my opinion, this is the easiest lesson because we're starting to solve quadratic equations. But specifically, the equations you're going to see on this lesson are in the form, or the quadratic part is going to be they're going to be ax squared and ax squared plus c. In other words, there's no middle bx term, okay? So we're going to look at how to solve these by graphing and by using square roots, okay? And both are pretty painless, all right? So our learning target for this lesson says we want to be able to solve quadratic equations by graphing, which we'll look at in example 1, and by using square roots, which we'll look at in examples 2 and 3. Okay, so with that, let's go ahead and get started with example 1A. Yes? No, I don't want an answer. I'm just going to go through them, okay? But thank you, though. So before we do that, let's go ahead and make this note, all right? So graphically speaking, solutions, and I would write this out, solutions are x intercept or intercepts. So that's what we're looking for. Where is the value of the function, which is the y value? Where is that equal to 0? Well, it's equal to 0 at the x-intercept. That's where y equals 0. Okay. So we're going to take a graphic approach first. All right. So what we want to do is we want to take our standard form kind of expression, and we want to type that into Desmos as y equals x squared minus 1. Okay. And then we've talked a lot about this, how to graph based on Desmos. I already have it in Desmos. So I'm going to pull out my corner points. So it looks like my vertex is at 0, -1. And then I'm going to get 2 points on either side of the vertex. So one is 1, 0. The other one is -1, 0. And then we also have 2, 3, and -2, 3. All right, so I'm going to go ahead and copy those onto my graph. 0 goes to -1. -1 goes to 0. 1 goes to 0. And then -2 goes to 3. And 2 goes to 3. So we see that nice parabola shape. I'm going to go ahead and trace my curve. So if we're going to use this graph to solve this equation, again, we're going to go back to our definition at the beginning that a solution or solutions are the x-intercept or intercepts, right? So we see x-intercepts. All right. X-intercepts right here and here. So we would say that x equals -1 and +1. So that's how you'll enter them into MathXL. If there's 2 solutions, you'll enter one solution, comma, then the other solution. So it's not an ordered pair, that's 2 solutions. Those are 2 values for x that we could plug back in and make that equation true. Okay? So this is one way to enter it. You can also, if it's like 1 and -1, you can also type that this way. You could say x equals plus or minus 1. There's that symbol on MathXL, if that saves you a little bit of time. All right, so let's do one more together, and then I'm going to have you guys try a couple on your own. Any questions before I move on to example C? I'm going to skip down to C. Yes, Robert? What did we say at the beginning? Solutions are what? All right, and where are x-intercepts? No, -1, 0, and 1, 0. So our solutions are those x values, right? Our x-intercepts are -1, 0, and 1, 0, okay? But the reason that those are solutions is because notice our equation is set equal to 0. So graphically, this means when I plug in -1, my y value is 0. When I plug in +1, my y value is 0. So that's why those are solutions, okay? Anything else before we move on? All right, let's try another one together. I'm going to leave B for you guys, so let's skip down to C. So that one says x squared plus 1 equals 0. So it really looks similar to the one we just did. I'm going to go ahead and pull up the graph. So the part I'm looking at is y equals x squared plus 1. All right, so based on what I'm seeing on my graph here, and remember I can pull up a table as well if I'm not sure. Looks like the vertex is 0, 1. And it looks like -1 goes to 2, +1 goes to 2. And then it also looks like -2 goes to 5 and +2 goes to 5. All right, so when I copy those on the graph, again, 0 goes to 1, -1 to 2, 1 to 2, and then -2 goes to 5, and 2 goes to 5. All right, so if I am looking for x-intercepts here, does it look like this? Does it look like this parabola is ever going to cross the x-axis? No, right? If its vertex is above the x-axis and it opens upward, there's always going to be that little void there between our graph and the x-axis. That this would be one that has no solution. All right. So the answer here, because of this little void, right? It's never going to have an x-intercept. This would be called no solutions because there are no x-intercepts, okay? So that can happen. So we've seen a case where we have two solutions. That's probably the most common case. We've seen a case where you have no solution. That can happen. All right, so those are some of the things that you can see. All right, I'm going to have you guys get about 3. Let's make that 3 minutes because you don't have to finish both of them. But see what you can do on C and D, at least as far as getting them. Or sorry, B and D, at least as far as getting them on a graph. And then we'll talk solutions. All right. So get about 3 minutes ahead of me here, and then we'll compare. We'll compare results. So you've got x squared equals 0, and then 3x squared plus 6 equals 0. you're having trouble, I'm going to start to write some stuff up that might be helpful. If you feel like you're doing good, keep doing what you're doing. All right, so I'm going to finish my graph for D, and then we'll talk solutions, okay? Make sure we understand what we're seeing as far as, on the graph, as far as what that means for solutions. So you did get some big output values on D. If you got that far, what I would do there is just scale my y-axis by 2, right? So negative 218 just looks like negative 29. Negative 1.9 looks like negative 4.5. And 0.6 looks like 0.3. Easy solution to that problem. I'm going to go ahead and finish by tracing the curves, and then we'll talk about the most important part, because we've talked a lot about graphing, so none of this should be really new. But interpreting the graph as far as its solutions, that's what's new for today. All right, so any questions about just the graphing part of it? Anybody having any trouble there? Taken from Desmos to your graph. Everybody okay there? All right, so looking at B, do I have an x-intercept? Yeah? Yeah, you do. Yeah, what is it? 0. All right, so it does go through 0, 0, right? So that would mean that my solution then would be x equals 0, right? So there we have a third case where you can have one solution. So you could have 2 solutions like we did on 1A. You could have no solutions like we did on 1C. You could have one solution like we did there, okay? So any of those things can happen. And then looking at my graph for D, how many x-intercepts do we have there? Yeah? No solution, right? No x-intercept. There's always going to be that void there between the x-axis and my parabola, right? Because 6 is my minimum value, so it's never gonna go to where y equals 0. So that would be a no solution. All right. Let me make, I guess, just one more point, and then we'll move on. So I said that solutions are x-intercepts. Another just vocabulary term, and I would add this. Solutions are also known as, I meant to write this first, AKA, they're called zeros. So solutions, zeros, x-intercepts, those are all synonyms when we're talking about solving quadratic equations. Solutions, zeros, x-intercepts. Okay? Any questions before we move on to the backside? All right, let's move on to the backside. And we're going to kind of go away from taking a graphic approach using Desmos, and we're going to take a more algebraic approach. You can leave Desmos open, though, because you can use it as a normal calculator as well. Or if you have your own, that might be helpful, too. All right, so example 2 says solve using square roots. Now, I've kind of alluded to this at the beginning, but it's important to know that this only works if there is no, I call it the bx term. So there can be an x squared term, there can be a constant term, but there could be no bx term. If there is, we got to have another way to solve it, like graphing, or we'll learn other ways. But you can't do this method unless you have these specific types of quadratic equations. This is the easiest way to do these. Graphing is not. So kind of just pay attention to what I do here. See if you have any questions. Try to follow along in your calculator. So let's just do 2a together. It says 3x squared minus 75 equals 0. So I'm going to solve this just as if it said 3x minus 75 equals 0. All right, so what would we want to do there? We'd want to get x by itself, so we'd move that over first, right? So doing plus 75 to both sides, and that's going to give me 3x squared equals 75. Then we would divide both sides by 3, right? And that's going to give me x squared, or 1x squared, equals 75 over 3 is 25. All right, and then what you're going to do is, well, I'm going to ask you. We just went over the inverse of subtract 75 is plus 75. The inverse of times 3 is divided by 3. What would the inverse of x squared be? What's the opposite of squaring something? How do you go back the other way? Yeah, square root. All right, so at this point, you would square root both sides. So then we get x equals, leave a little space there, but what is the square root of 25? 5, right? All right, so here's the one thing people forget when they do this, all right? And I would put a little note here on this first one. Say there are two real, I'm just going to put SQ short for square. There are two real square roots. And then in parentheses, I'm just going to put this symbol that looks like a plus sign over top of a minus sign. So that means plus or minus. All right. So when you take the square root of both sides, you have to use this plus or minus symbol. Okay. So what that means is, and this is fine for a final answer, but what we're literally saying is x can be 5 or it can be -5. Both are true. Okay. Now, why is that the case? Because a negative times a negative is a what? Positive, right? You guys have heard this before. We just forget it. So, 5 squared is the same thing as -5 squared, right? So if I plug in either one, it's going to make this equation true. Okay? So don't forget the plus or minus symbol when you use this easy method to solve. Okay? That's the one thing that you would forget. All right, let's do one more together. Then I'm going to have you guys try a few. Forget which one I was going to do. Let's see. I was going to leave you guys B, C, and E, so we need to do D. Let's do D together. All right, so D is, similar, but a little bit different. So first thing we want to do, move that plus 16 from the left to the right side. So step 1 is minus 16 to both sides. On the left side, that's going to leave me with 4d squared. On the right side, it gives me 16 minus 16, which is 0. Then we divide both sides by 4, which it doesn't matter what we're dividing by. If 0 is on the other side, we're going to get 0. 0 over 4 is equal to 0. All right, and then you're going to take the square root of both sides, which, what's the square root of 0? 0. So if we put plus or minus 0, is that 2 solutions or is that 1 solution? It's really just 1, right? Is there a negative 0? All right, so this is the one case where you don't really have to use the plus or minus sign. So let's just say don't need if solution is 0. So my only solution here, this is a one solution example, would be that just D equals 0, because there is no negative 0. Okay? All right, so I'm going to have you guys then try the rest of those. You'll make at least one mistake, even if you do everything right, and that's okay. Just do what you can in the next 3 minutes, working on B, C, and E. Feel free to work with your neighbor. Some of you may only get one of them done. Some people may get none of them done. Try your best. Some people may get 3 of them done, right? Different people work at different speeds. But don't just sit there and do nothing waiting for me. Try B, C, and E. Or at least what you can, okay? Feel free to compare answers if you get finished with any of them. And I'll probably just kind of go through those versus calling on you. Just so we do get through all these examples, because I think this is more of a one-day lesson. Yeah, the ones we left blank. That's a good question. All right, a few more seconds, and then we'll talk about all 3 of these. All right, so I'm just going to go through these, and I would just say a side note on just checking your answers. So like any other equation ever, you should be able to plug your answers back in for the variable and see if they work. But also, since we're using Desmos, it may be easier just to type them into Desmos and then see if the x-intercepts line up with your answers. Okay, so you'll have to decide what's the best way for you to check your answers. All right. All right, so let's just go through it. Stop me if you have any questions, okay? So looking at B, example B, we want to isolate the m squared part first. So add 36 to both sides, and we get m squared equals 36. Everybody's like, I thought m squared equaled E, right? No, that was an Einstein joke. E equals mc squared? Nothing? Okay. That's all right. That's all right. It is the theory of relativity, yes. All right, then we take the square root. The only thing we don't want to forget is the plus or minus sign, okay? So we get m equals plus or minus whatever the square root of 36 is, which would be 6, right? So positive 6 and negative 6 are your two solutions for B. All right? Any questions on that before we move on? That one's easy enough. C is kind of like A, okay? So move the plus 15 over. When we do, we get 3x squared. Let me put a little spacer there. Equals 0 minus 15 is negative 15. Then we'd want to divide by 3. So that would give me 1x squared equals negative 5. And then we get x equals plus or minus the square root of negative 5, okay? So if you didn't already figure this out, let's type that in real quick. It's good to know how to type that in too. So if you have your calculator, that would be, you hit the second key and then x squared. That pulls up your radical, second and then x squared. And then if we type negative 5, what's it say? Domain error, okay? So that's a good reminder that you can't take the square root of a what kind of number? Negative, right? So we've been told this before, but we forget these things, right? There is no number times itself that equals a negative, okay? So this would be what a no solution looks like, all right? No solution, and I would just remind yourself here that you can't square root a negative. So anytime you get to 1x squared equals negative whatever, it's a no solution, okay? And again, you shouldn't have known that, but if you caught on to it, good for you, okay? Any questions on that before we move on? So graphically, if we graphed y equals 3x squared plus 15, we would see a parabola with no x-intercepts. That's what we would see, okay? So E, we want to add 25 to both sides first. That would give me 5x squared equals 20 plus 25 is 45. Then divide both sides by 5. On the left side, that gives me 1x squared. On the right side, that gives me 9. Then we're ready to go ahead and take the square root of both sides. So we get x equals plus or minus, what's the square root of 9? 3. So that's another 2 solution example. Now, I would say this about graphing this one. You don't necessarily have to write this out, but to graph, let's say if we wanted to check our answers, what you'd have to do is write it in standard form. So you'd actually want to move the 20 over to the left side. So you'd have to write it like this. 5x squared minus 45 equals 0. And then you could graph y equals 5x squared minus 45. So that would be a little trickier to graph, okay? That's called putting it in standard form first. Anyways, any questions about any of this solving by square roots? Okay, so the key will be recognizing, this is the easiest way to solve them, but being able to recognize when can I use this method versus when can I not, okay? All right, so let's finish with 1 or 2 of these word problems. We may have time for both. I know on the screen that looks terrible, so you'll just have to listen to me read this. You guys have the paper in front of you, so maybe follow along with me. So I'm looking at 3A. It says an aquarium is designing a new exhibit to showcase tropical fish. The exhibit will include a tank that is a rectangular prism with a length L that is twice the width, W. Then they give us the volume is 420 cubic feet. What's the width to the nearest foot, it says, okay? All right. So, and again, I know this diagram is impossible to read just because I guess the image I clipped wasn't too good. But anyways, here's what we have. This dimension right here is called the height. And it just says that's 3 in the diagram. So height is 3 feet. All it says is L right here, but what they tell me about L, I need. All right. So if we go back to what I was reading, it said that the length is twice the width. So I'm gonna say L equals 2 times W, and then all it says here is W. Okay. So those will be my dimensions. All right. To get the volume of a rectangular prism, that's easy. Everybody always knows this one. It's just volume equals length times width times height. You guys all knew that. So let's sub in what they've given us. All right. So what they've given us is that the volume itself is 420 cubic feet. So I'm going to plug that in over here. The length, we're going to sub in 2 times the width for, right? Length is equal to 2W. So I'm going to sub in a 2W there. The width, we don't know anything about, so we're just going to keep that as W. And then the height, we can sub in a 3. So overall, now we have an equation we can solve. 420 equals 2W times W times 3. First thing we want to do is simplify the right side. So if we multiply all that out, 2W times 3, we would get 6W squared. And then we're just trying to solve for W, right? So step 1 would be divide both sides by 6. That gives me 70 equals W squared. And then take the square root of both sides, and we get, it ends up being about, why don't you type it in real quick? What is the square root of 70? We know the square root of 64 is 8. Square root of 9 is 81. So somewhere between 8 and 9 it should be, yeah. About 8.3, 8.4. So we could say plus or minus 8.4 is about equal to W. Now, on these word problems, they want you to put it into context. So if we're talking about the width of a rectangular prism or the width of an anything, which one of those two solutions makes absolutely no sense? The positive one or the negative one? Can we have negative feet? No. No, right? So the negative one doesn't really apply. So we just say the negative solution is not applicable. So just to finalize our answer then, we would just say that the width is about, they say round to the nearest foot, so we'll say the width is about 8 feet. We ignored the negative solution and we rounded it to the nearest foot. Okay? All right, so since we are pretty close to the end, I'm going to hold off on doing that last one. It's basically the exact same problem. It'll be on your filled out notes, and I'm happy to show it tomorrow in class. So in tomorrow's class, we will do what we have been doing. I'll give you time to work through the Math Excel. It'll post at 3 p.m. after school if you want to do any for homework to get ahead. I always encourage you to do that, but you don't have to because you'll have time in class. I'm going to go ahead and stop the recording there. Yes, absolutely. You can do it all if you want to. No problem with working ahead.